Hello, this is Alternative Delivery for Math 1115 for 25th of March. We're going to go over the quiz that you've worked on for Chapter 3 and 4. And I will be going over the solutions. This is to be self-graded and self-reported prior to spring break. We'll say a little bit more about that later. And please feel free so that we're continuing to learn to use the play, pause, and rewind buttons in YouTube. And I want to commend you because we are being flexible like trees in the wind. We are working very hard to ensure that teaching and learning can continue unabated. And although that's first priority, grades are important also. And so today is proof that in fact grades can be earned by your work on this quiz. And as you report them, grades can be in fact rendered, and there's no reason that your educational goals can't not be achieved this term. It won't be as easy, but we can do this. I'm proud of you. Okay, the rubric for the whole quiz is each numbered problem is worth 10 points. Report to me via email the number of points you earned, and I will divide it by 120 and record that as a percentage when I get a chance to do so. Certainly partial credit is allowed, and I will let you use your own good judgment on such things. I will not conduct an audit on this quiz. And this is our last class prior to spring break, so let's make it a good one. Okay, so the first problem here says that we're looking at the x-coordinate of all points on the y-axis has to be 0, since all points on that line have the form 0y, where y can be any real number. The next one, each of these should be worth like 1 point. The y-coordinate of all points on the x-axis is 0, since all points on that line have the form x comma 0, where x can be any real number. You don't have to say this exactly the same way. Use your judgment about what you said. All points for which x is greater than 0 are in quadrants 1 or quadrant 4, and to the right of the y-axis. All points for which y is less than 0 are in quadrants 3 and quadrant 4. All points are below the x-axis. All points for which x is less than minus 1 are in quadrants 2 and 3. To the left of the line x equal minus 1, which is parallel to the y-axis, 1 unit to the left of the y-axis. All points for which y is bigger than 4 are in quadrants 1 and 2, above the line y equal 4, which is parallel to the x-axis, 4 units above the x-axis. If x times y is greater than 0, then the product must be positive. That means that either the coordinates are both positive, x equals x greater than 0, y greater than 0, which is quadrant 1, or both negative, x less than 0, y is less than 0, which is in quadrant 3. So the answer is we're in quadrant 1 or quadrant 3. If the ratio of y to x is less than 0, then one of the coordinates must be negative. Therefore, the sign of each coordinate must be opposite, and so you could be in quadrant 4, where x is bigger than 0 and y is less than 0, or you could be in quadrant 2, where x is less than 0 and y is greater than 0. If x times y is equal to 0, then the product of the coordinates must be 0. Therefore, each coordinate could be 0. So either you're on the x-axis or the y-axis. The last one, if x is less than y, then the y-coordinates of all points must be higher than the x-coordinates. All points whose x-coordinates equal their y-coordinates are on a 45-degree line through the origin. And the equation is y equal x, which bisects the first and third quadrants. So we have x less than y for all points above the line y equal x. Number 2, we were to solve the triangle completely. We were told A was this and B was this. And this is angle A and this is side B. So angle B is going to be the difference between that and 90, so B should be 42.7 degrees. Then we can solve for what a is, lowercase a, because a over 8.25 is the tangent of this 47.3 degrees. So we found out what a is, and c can be found from the Pythagorean theorem. And so what happens is that the Pythagorean theorem is you add those the square of those two sides together, and you get what c is, and so c is 12.16. Question 3 is a little bit similar in that we're solving a right triangle. So we're given values for A and C, that is side A and side C. So one thing that we can do is we can use the Pythagorean theorem to find out what side B is, but this time it's going to be B is equal to C squared minus A squared. So we'll get B is 2.87. Angle A is going to be the inverse sine of 9.84 over 10.25, and so you should get 73.74 rather for that. And if you subtract that from 90, you get that angle B must be 16.26 degrees. This is question number 4. I ask you to solve the triangle completely if A was 45 degrees. Well, there are many triangles where that is 45 degrees. So the only two things that you really could state is that B has a measure of 45 degrees and the sides, ABC, have a ratio of 1, 1, and the square root of 2. That is a special triangle. I do expect you to know that. Question 5 was sort of a similar one in that it was a special triangle. So we say solve this completely if A is 60 degrees. Well, if A is 60 degrees, we can only state that B measures 30 degrees. But since this is a 30, 60, 90 right triangle, we could state that the sides A, B, C are in a ratio of, in this case, the square root of 3, 1, and 2. Again, that's a special triangle. I expect you to know those ratios and be able to use this in your problem solving. Question 6, we have 2 legs. Now I don't tell you which leg is which. One is 5 and one is 12, and so you get to report on this in that manner. But if we have sides that are 5 and 12, we know that there is one angle that's going to be the arctangent of 5 over 12, and that one is going to be 22.62 degrees. I rounded that to 23 in my answer. The other one has to be 67. And we can say 12 squared plus 5 squared is the square root of 169 or 13. So the answer to this is the acute angles measure 23 degrees and 67 degrees, and the hypotenuse measures 13 units. Question 7 had 2 parts, count them 5 points each. You would find the tangent of theta if in fractional form the sine of theta is equal to 2 over 3. You draw that triangle and you say, oh, the opposite is 2, the hypotenuse is 3, so that is going to be 9 minus 4, so the other side squared is going to be 5. So the tangent of that angle, theta, is going to be 2, the opposite over the remaining side, the adjacent, which what we found to be the square root of 5. Part B says find the cosecant if the tangent is equal to this. Now, this is a calculator problem, but is also a complicated calculator problem because you see you don't have a button for the cosecant, but we remember that the cosecant theta is 1 over the sine theta, and so that's what we're going to do. So if you were using your calculator and wanted to do one line, what you would say is that well, what is the inverse tangent of that angle, and then what's the sine of that, and then this minus 1 here says we do turn that upside down, so that really is the cosecant. If you do all that, you get the cosecant of theta is 1.264. Question number 8, we had this drawing, and we were to find the length of the third side. That's the side that is down here called S. We know from our geometry chapter that this perpendicular bisects that angle, and so we can say that S over 2, let's just use one of those, so S over 2 divided by 12 is the adjacent over the hypotenuse, and so that means S over 2 is equal to the cosine of 42 degrees. You plug that into a calculator and you find out that S has to be 17.8. Question number 9, we want to know how far from its course to the east of the ship. So you let x be the distance from course to the east, and then we have this this triangle. And so we know that x, this angle here, is the 4.05 degrees, and so we have x divided by the hypotenuse 22.62 is the sine of that angle. That's the opposite over the hypotenuse. So x is equal to 1.598 kilometers. Question number 10 dealt with a communications satellite. You want to know what's the greatest latitude where you could where a signal can go from the Earth's surface to satellite in a straight line. Well, here's the picture. So this is the satellite that is out here, and the its orbit directly above the Earth's equator. So that tells you this, you know, what that distance is. This distance right here, and the radius of the Earth is 6,400 kilometers. They're rounding that off, and that means this radius is 6,400 and that radius is 6,400. We do know that that what will happen is this tangent line, which is what the problem is asking us for, is perpendicular to the radius. So this is a 90-degree angle, and so we can have a triangle that we can solve. There's the angle that we want to find, because that is how the latitudes are described. And we start with 0 here and we go upward, so that is the angle that we need. And we'll say that the cosine of that angle is going to be the adjacent divided by the whole of the hypotenuse. And so then I can take phi to be equal to the inverse cosine, and I get it as 81.2 degrees. That was a very good problem, I think. Problem 11 dealt with this loading dock, and the question was asked, how much longer should the ramp be to reduce the angle that it makes to the ground to 4.5? So you draw this picture. Here was the old configuration. You make the ramp longer instead of that. So instead of 9.5, you make it longer, and so that you have an angle here is 4.5. So if you let x be the new length of the ramp, then the sine of 4.5 degrees is going to be the opposite over the hypotenuse. So we can solve for x, and we get x is 31.9 feet. Here's a calculated version of that. But that means how much did we add? Well, we subtracted from the original, and we had to add 22.4 feet. Question 12, we were to find the angle theta, and theta is the entire angle through here. Now we know from our geometry chapter that this theta is bisected, and so we can look at this, and this is also bisected. So what we do is 42.5 over 2 divided by this distance here, so that tells us that's what that distance is, divided by this distance is the tangent of theta over 2. So we can use our calculators to say that theta over 2 is the inverse tangent of this ratio. That means theta over 2 is this in degrees, and that means that theta is equal to 6.49 degrees. Now more than ever, time is precious. Each day must count. Do the math. It will make you strong. Be careful on spring break.